Hello everyone. I would like to continue with the previous video. In previous video, we are working with washer method to find the volume of a solid generated by the area bounded by the given curves. Okay, so in reviewing the washer method, I would like to go back to our formula sheet. So on our formula sheet, we were talking about this formulas right here to calculate a volume of a solid using washer method, and the axis of rotation is the x-axis, then we are going to work with these formulas. So this formula asking us to take the upper functions, square the upper functions, subtract the square of the lower function, and integrate that in terms of dx, apply fundamental theorem of calculus, multiplied by pi will give us the volume using the washer method. Okay, so in working with the upper and the lower function, we have to be very careful so that we know which one is the upper and which one is the lower. Okay, so going back to our lesson, in order for us to achieve that, we must shade in the area that we are working with. So in this particular example, I have two parabolas. Okay, two parabolas. And the points of intersection of these two parabolas is actually here. So this point and this point. Okay, so these 2 points are the A and the B that we are talking about. So here A, B. So let's write down the formulas that we need to work with. So I will have to use V equal to pi integral from a to b of y2 square subtract y1 square. So y2 square subtract y1 square, and this in terms of x. Alright, okay, so if you place your it's between this area that we are working with, then you will recognize that this part here, this parabola, is the upper function. Okay, so this parabola here is the lower function. Okay, so in recognizing which one is which in this case, you see that the parabola opens up is the one that has the positive a. So this is positive x squared, positive 1 of x squared. So this one is the parabola opens up. So this one is y equal to x squared. Okay, the ones that is opens now is y equal to a minus x squared. Okay, because the value for the coefficient in front of the x squared, or the value for a, is a negative value. So this one opens down. Okay, so which one is the upper function in this case? So place your eyes within this green area that we just shaded, or you are going to draw your element, which is the vertical element. Okay, in vertical element right here, obviously this is your y2 and this is your y1. Okay, so your upper function is the parabola opens down, and the lower function is the parabola opens up. So that's why in previous video, in explaining this for everyone, I was telling everyone to make sure that you concentrate your view into the shaded area. So if you look outside, okay, if you look outside, then it tends to be your parabola opens up here is the upper function, and this one is the lower function, but it's not. Okay, so make sure that you are working with the area that indicated to you. So it's very important to shade this area in and then realize which one is the upper function and which one is the lower function. So I'm going to draw the arrows down. Okay, so to show you that, you take the upper one and then you subtract the lower one. Alright, so before we do that, why don't we figure out A and B? Okay, so in figure out A and B, you are going to let the two functions equal to each other. Okay, so I'm going to solve for A and B by, solve for A and B. So let y2 equal to y1. Okay, so I will have a minus x squared equal to x squared. Okay, so let's do this. 8 equal to x squared plus x squared. So in this case, I will have 8 equal to 2x squared. So now you are working with the pure quadratics. Okay, pure quadratics, you can have just the coefficient or the c value over to the other side. Pure quadratics, you don't have to have the side equal to 0. You move the, you can have c, value of c over to the side. So you divide this by 2. Okay, so then this will be equal to 4. And you will have two solutions for this. Take the square root of both sides. But because you are working with the quadratic, and it's a pure quadratics, so you need to have the opposite values of whatever the square root of 4 equal to. So in this case, you will have x equal to 2 or x is equal to negative 2. So don't forget that. It's a quadratic equation with exponent of 2. The exponent 2 will tell you that you must have two solutions for x. So in this case, I will have this equal to 2 and negative 2. 2 and negative 2. Alright, very good. So why don't we square the upper function and we square the lower function as well? Okay, so I have y2 square, so I have a minus x square, all of it square, so that means you are going to multiply this expression by itself twice. Okay, and then I apply the concept distribute multiplication of each term for the second bracket here. Multiply each term of the first bracket into each term of the second bracket. So I should have is equal to 64 subtract 8x squared subtract 8x squared plus x to the exponent 4. So it's equal to 64 subtract 16x squared because I collect the two terms. Two like term, so it's x to the 4. So this is my y2 square. Okay, what about y1 square? So y1 square is equal to x squared, all of it to the exponent 2, so I have x to the exponent 4. Okay, so let's put this into a box, and we are going to subtract these two equations. Okay, and we are going to substitute it into the equation to solve for the volume as well. Okay, so I will have v equal to pi, the integral of negative 2 to 2, okay, of y2 square, so 64 subtract 16x squared plus x to the 4 subtract x to the 4. Okay, so all of this is in terms of dx. So this one is my y2 square, and this one is my y1 square. Alright. Okay, excuse me. Okay, so now you see that you can open up the brackets, and that is cancelled with that. So what you have is now pi multiplied by negative 2 to 2 integral of 64 minus 16x squared dx. Okay, so now pi multiplied by integral of 64 is 64x. Integral of 16x squared will be 16 over 3x to the exponent 3. Okay, definite integral -2 to 2. And now make sure that we remember that we apply the fundamental theorem to the f of 2, subtract the f of -2. Close the bracket. Okay, so we have to be careful here. So volume equal to pi, and I'm going to multiply this with the integral of 64 times 2. Subtract 16 over 3 times 2 to the exponent 3. So this is my f of 2. Okay, I'm going to subtract this with the 64 times -2. Subtract 16 over 3 times -2, all of it to exponent 3. So don't forget that all of it to exponent 3. Okay, so now volume equal to pi. This I should have 128 subtract 128 over 3 subtract -128 and plus 128 over 3. Okay, so this is my f of -2. I have to remind myself that. So let's take a look at this. Okay, so -2 to the exponent 3 is -8. So you raise a negative to an odd exponent, so you still have an odd result. So -8 times 16 as a negative will give me a positive 128. So let's open this bracket and see what we get. Okay, so in here I should have this equal to I can go ahead and open this up actually. Okay, so this one I can have is 128 subtract 128 over 3 plus 128, and then this one I should have it as, so that time that, so that will be subtract 128 over 3. Okay, so in a way that I have it equal to 128 plus 128, I should have 256, and subtract this two values, then I should have it as subtract 256 divided by 3. Okay, so everyone can use a calculator and do this at the same time with me. Okay, so I should have this equal to 512 over 3. Okay, and multiply by pi. Unit Q. Alright, so this is very simple anyway. So everyone is know how to use calculator. You can go ahead and just perform all of this stuff using your calculator, but I just want to break it down to these two values. Okay, so if I ask you, like, you have to indicate the FB and the F of A, then you can do it like this. Okay, so let me draw this, and then I will write it here for everyone. V equal to pi, and if I post the solution and I have something like this, so that means I have 256 divided by 3 subtract negative 256 divided by 3. Okay, so that means here I am asking everyone to indicate to me the F2 and indicate to me the value of F of -2. Okay, so then f of 2 will be equal to 256 divided by 3, and then f of -2 will be -256 divided by 3, and you see this also gives the same values as 512 over 3 pi unit Q. All right, okay. So let's see what this shape looks like. All right, the 3D shape for this one will look like this. Okay, all right. So I just want everyone to see that this is your upper parabola. Okay, so this is your lower one. So the upper parabola is y2 is equal to 8 subtract x squared. The lower one is this one right here. So this is your y1, which is equal to x squared. Okay, so this shape will look like this. In order for me to take this image for you, I have to place it in this position, so it tends to fall off. So I have to place my iPod, my earpod beside it, so it has something to lean on, so it will stay for me to take the image. Okay, so if you can just ignore this part here, this is not the shape that we are talking about. It's just the earpod. Okay, and let me draw the axis of rotation. Here the axis of rotation, and here is the axis of rotation as well. Okay, so this is my y, and this is the x. Axis of rotation is the x-axis, and what is the area that we are working with? Is this area. Okay, so let's choose this color. So this is the area that we will shade it. Okay, and then we rotate this shape about the x-axis, and we are forming this 3D image, okay, or this solid. So let me show you what it actually looks like. If this is the cross-section part of it, the full solid would actually, okay, so here is the half, the cross-section to show you the area, and here is the actual shape. Okay, yeah. Now the next one is I just place them on here's for you to show that I cut this one in half. Okay, so I post this document as well. Okay, I post the document as well. So if you want to review the document again one more time, you can go ahead and open the document and examine it for yourself one more time. So this is -2 and 2. Okay, so this is just a base for me to have this one stand up. Okay, so this is not any shape. I thought it's a good idea to put it here with my my name on it, so that I can say that this is my work as well. Okay, so anyway, thank you everyone. I will continue with the example number 3, okay, on the next video. Alright, thank you.